Hello students, so let us continue with our chapter, right? So today the topic that we are going to study is balancing the chemical equations, right? Okay, let us dwell deeper. Okay, so in this presentation, we are going to study step by step how to balance equations, what are the basic principles of balancing the equation, right? Okay, so firstly, what is the need to balance the chemical equations? Like we did study it in the last video, but let us again revise, right? What is the need to balance the chemical equations, right? Firstly, let us understand what is the law of conservation of mass. The law of conservation of mass, it states that mass is neither created, it is neither destroyed, right? So it can form new products, right? Just like law of conservation of energy, yes. Okay, so, unbalanced equation violates the law of conservation of mass. That is one of the reasons that we need to balance the chemical equations, right? And according to this law of conservation of mass, on the left-hand side and the right-hand side of our equations, there should be equal atoms, okay? Equal atoms of each element to maintain this fundamental law, that is the law of conservation of mass, okay? Now, in the last video, we took an example of H2 plus O2, which gave us H2O. This type of reaction, which is not balanced, we call it a skeletal equation, right? So unbalanced equation is equal to skeletal equations, right? So this type of equation, it shows the reactants and the products without proper coefficients, right? They are not showing us proper coefficients, right? But a balanced chemical equation, it shows the correct chemical equation. It follows the law of conservation with proper coefficients, right? Let us try to balance this equation quickly here. Okay, so here we have two hydrogen atoms that are balanced. We need to balance oxygen atoms. There are two oxygen atoms. Okay, so I need to put a coefficient here, right? So I'm putting coefficient here, that is 2H2O, but now my number of hydrogen atoms have changed. So I'll put 2 here again. So if I would see on the left-hand side and the right-hand side, the number of hydrogen, okay, hydrogen and oxygen, the number of hydrogen and oxygen, okay. So here the number of hydrogen is 4, here also it is 4, the number of oxygen is 2, and here also it is 2. So our equation is balanced. We are going to study the proper rules from the next slide. This is just to make you all understand that this is what is known as a balanced chemical equation, a correct chemical equation which follows the law of conservation of mass, right? Okay, let us understand step by step what are the rules to balance the equation, right? First is we write the skeletal equation, whatever is the equation given to us, with the basic formula which shows the reactants and products, right? Next, you are going to count the number of atoms, both on the left-hand side and the right-hand side. Okay. And so now your doubt would be, ma'am, which element should we balance first? First, you should balance the element that is present in maximum number, the element that has maximum number of atoms, right? That is what you should balance first, always, the one that has maximum atoms, right? Next is always use coefficients. What is coefficient? In the last slide, I gave you the example, 2H2. So I wrote 2 here. I added 2 here, right? I did not mess with the formula of H2O. I did not make it H2O2. No, I cannot make it H2O2, right? I can only add a coefficient in the front, right? I cannot, change the formula. Right, students? So you always use coefficients, right? You have to use coefficients. We cannot change the chemical formula. Next is balance one element at a time. Otherwise, it will create a lot of confusion. So we need to balance one element at a time. And this method is a hit and trial method. Like we need to balance everything one by one, and then we need to verify, yes, recheck everything till the time we get a proper balanced equation. Also, at the end, we add the physical states. If your reactant is present in gaseous state, you put a small g. If it is present in a solid state, you put a small s. In liquid, you put L. If it is an aqueous condition, now you would be asking, ma'am, what is aqueous condition? Aqueous condition is when your solid is dissolved in water, so we call it aqueous, right? For example, you have copper sulfate salt and you mix it in water, so we will call it to be in aqueous conditions, right? Okay, now let us put these rules into practice. Okay, so we have our equation that is what we had studied in the previous video, burning of magnesium in the presence of oxygen. So first I'm going to write the skeletal equation, Mg plus O giving me Mg plus O2 giving me MgO. Let us count the atoms. Okay, so if I count, there is one magnesium, right? But oxygen is, okay, if I would write here left hand side, right hand side, you can also make such table for your convenience. So magnesium is 1 and magnesium is 1 on both the sides. Oxygen is 2. Here it is just 1. So we need to balance the oxygen first, right? Because even on the left hand side we have two oxygen atoms. Let us start with oxygen, right? So what do we need to do? Okay, right hand side oxygen are less, so what can I do? Can I write it as MgO2? What do you think? Yes, you are right, we cannot write it as MgO2, that will be wrong. We need to add a coefficient, so we add a 2 over here, it becomes 2MgO. Now let us check. Okay, now the number of oxygen is balanced. Okay, I'll write 2 over here. But let me check. Magnesium. No, no, no. Magnesium is not balanced at all. Can you see magnesium? Here it is 1 and here it has become 2. So what do I do now? I put 2 here, right? Now let us check. Yes, so we have 2 magnesium on the left hand side, 2 magnesium on the right hand side, and oxygen are also balanced, right? Hence, now the equation is balanced and it is in accordance with the law of conservation of mass. So as you can see here, this is our final balanced equation. Okay, now let us move forward. We have another skeletal equation, that is zinc plus H2SO4. Do you all know what is the name of H2SO4? Yes, it is sulfuric acid giving us zinc sulfate plus hydrogen. Let us check, is the equation balanced or not balanced, right? So again, let us put left hand side and RHS. So zinc, we have hydrogen, we have sulfur, and we have oxygen. So how many zinc atoms are there? Let us count together. Yes, you are right. There is one zinc on the left hand side. There is one zinc atom on the right hand side. Hydrogens. Okay, there are 2 hydrogens on the left hand side and 2 hydrogens on the right hand side. Sulfur. Yes, there is one sulfur on both the sides. Oxygen. Yes, you're right. There are 4 oxygen atoms on left hand side and right hand side. So after counting the atoms, we have come to a conclusion that here the left hand side and right hand side both are balanced, right? So result is our equation is already balanced, right? So some equations, they are naturally balanced from the start, right? So no need to worry that, this is being given in the exam and what to do. So you can write that some equations are naturally balanced from the start. Okay, now let us work on this equation. So we have Fe, that is iron, plus water, giving us an oxide of iron, Fe3O4, plus hydrogen. Let us see if this equation is balanced or not. First step is write the skeletal equation which we have written. Next step is to check. Okay, so I can clearly see that my equation is not balanced because Fe we have 1 on the left hand side, on the right hand side I have 3. Oxygen I have just 1 on the left hand side and right hand side I have 4. Hydrogen is balanced. So now I need to balance my equation. So as we had studied, you need to start with the element which has the maximum number of atoms. You can see here oxygen has 4 atoms, right? So we start with oxygen. What do? We balance oxygen. How do we balance oxygen? I'm going to put the coefficient 4 here. I cannot write H2O4. That will be wrong. I can only put coefficient. I cannot change my formula. Okay, so we are happy. We have balanced Fe plus 4H2O, giving us Fe3O4 plus H2. But wait. What happened? Hydrogen became unbalanced. You see, there are 8 hydrogen atoms here, and here there are just 2. We need to change it. Simply, how can we change it? Let us make this 8, right? How can we make it 8? I'm going to add a 4 over here, right? Now let us check. Yes, our oxygens are balanced. We have 4 oxygen on both the sides. Now again, we are going to make a table to make our work easy. So I have iron, I have hydrogen and oxygen. Iron is not balanced, 1 and 3. Hydrogen, we have 8 and 8, that is balanced. Oxygen is also balanced, right? Now our work is to balance iron. So there are 3 iron atoms here. What we can do, I can place 3 here, right? So now my equation is balanced. Let us verify. 3 iron on the left hand side and right hand side, 8 number of hydrogens on the left hand side and right hand side, and 4 oxygen atoms on the both sides. So this is how you verify at the end. You need to check it. This is a very, very important step. Hence, we have achieved our balanced equation, right? So these are the state notations which I have already told you about. That is, at the end, you can add it, right? So we're going to add it here. That is, our iron is in the solid form, right? Okay. And here the hydrogen is in the gas form, iron oxide is in the solid form, and here H2O is again in the gas form, right? So which you can see here, the water is actually present in the form of steam, right? This is the complete balanced equation. Okay, now let us do a quick recap. We are coming towards the end of the topic. Firstly, you write the skeletal equation. Skeletal equation shows us the basic reactants and products, but a balanced chemical equation follows the law of chemical, the law of conservation of mass, right, with proper coefficients. Next, this is a hit and trial method. You start with the most complex compound or the compound that is having the maximum amount of atoms. Next is you never change the formulas, right? You can only put coefficients. Last step, you add the state symbol, solid, liquid, gas, gaseous, or aqueous, right? Okay. So this is a quiz time for you all. You need to, solve this and, comment the answers below the video, right? So I have given the hints to you all, right? So please do try these questions out, right? To check your understanding, how much you have understood, right? Okay, so here we come towards the end of our class, right? So balanced equations is equal to balanced science, right? Okay, so it takes practice, like learning of language take practice, learning of chemical equations do take practice and a lot of patience, right? So keep on practicing. Yes, and you can learn more with me. You can learn in detail. You can contact me through my Urban Pro profile, right? Okay, so thank you all. Thank you for watching the video. See you. Thank you.